So today we're going to start solid geometry. Obviously this won't be on this week's test, but this is the next unit that we're going to be doing. So we're going to be doing three-dimensional figures. They can be made up of curved or flat surfaces. Each flat surface is called a face, and the intersection of two faces is called an edge. And the intersection of two or more edges is called a vertex. So here we have a basic three-dimensional shape. Any of the segments are going to be edges. The points are going to be vertices. And any of the flat surfaces like this one will be a face. Now we're going to talk about different kinds of three-dimensional objects or solids. First one is a prism. A prism is formed by two parallel congruent polygonal or polygonal, doesn't matter which way you pronounce it, faces called bases connected by faces that are parallelograms. Usually rectangles, but not always. They can be just parallelograms. It can lean to one side. So this is a prism. It's a prism with a triangle for a base. You can also have a rectangle for a base. You can have a trapezoid for a base. You can have any kind of polygon you want for a base. A cylinder is very much like a prism in that it has two bases, but the bases here have to be circles. Now, they also have to be, just like with a prism, they have to be parallel and congruent to one another. And then they're connected by this curved surface. There's not really any edges in this, nor are there any, the bases are faces, but that's it, and there are no vertices in this one. Now, a pyramid is formed by a polygonal base. Usually when you think about pyramids, you probably think about square pyramids, right? If you think of an Incan or an Egyptian or Mayan, any of those pyramids, they all had square bases. But they don't have to. They can have an octagon for a base. Okay? This particular one has a triangle for a base. And then the sides, if you will, meet at a common vertex, sometimes called the vertex. Now, these are all vertices, but that one's usually called the vertex. And then a cone is a lot like a pyramid, except that it has a circle for a base. All right, so moving on. We're going to talk about volumes and areas in prisms and cylinders. So a lateral surface is any surface that is not one of the bases. So it can be curved, it can be flat, but any surface that's not one of the bases is called the lateral surface. The lateral area is the sum of the areas of the lateral surfaces. Now with a cylinder, that's just one big long, curved surface. But for prisms, you have all those rectangles or parallelograms that go from one base to the other. Then the surface area is the total area of all surfaces, so that includes the two bases. And then the volume is the number of non-overlapping unit cubes that will exactly fill the interior. How many cubes does it make to build this thing, or to fill it up if it's hollow? So the problem, which makes it more difficult to visualize. What has to happen is you have to cut a whole bunch of the cubes. Yeah, it doesn't fit nicely, does it? So if we took a triangular prism like this one and opened it up, we would have these three lateral faces and these two bases, right? And h here would be the height of the lateral face. It's also going to be the height of the prism. It's the same thing. These two are the same. This distance all the way across all three lateral faces is going to be the same as going from here to here, then here to here, then here to here. That's the perimeter of the base. So that's just it unfolded, if you will. So for a right prism or a cylinder, the lateral area is the perimeter of the base times the height, because this makes one big rectangle here. Notice it says a right prism. That means ones that stand straight up and down. If it leans to one side or the other, it's a lot more complicated. You've got to do each face individually. Then the surface area is the lateral area plus 2 times capital B. Capital B stands for the area of the base, because if it's a prism or a cylinder, it's going to have 2 bases. And then the volume is the area of the base times the height. Now, the reason for that is the area of the base would tell you how many cubes it would take to cover the bottom 1 layer thick. And then the height is, well, how many of those layers do you have? Okay, so those are our formulas for prisms and cylinders. Yes, ma'am?
So just by looking at like the open one, would the bottom of the 2 lateral faces
There's 3 lateral faces.
of the side lateral faces
Uh-huh.
equal the bottom of the middle?
No.
So if you're doing perimeter, wouldn't the bottoms of the outside lateral faces overlap the base? So isn't that like
No.
you like fold them on it?
So it looks like that.
Yeah.
And then when we unfold it, it looks like this.
Yeah.
And what we have at the bottom is the perimeter of that triangle. But what?
Like I get it, but like it makes sense. But the base. Wait, hold on. So if you have the base is at here.
Right, but say we had a triangle
Yeah.
up here and a triangle down there, yep.
This.
When you unfold it, this would fold up that way, and the other one would fold down to the bottom.
But isn't this on this?
Yeah, but I cut them open.
So this, how does that equal that?
Because this is that. This piece and this piece are the same length. And this piece and that piece are the same.
Yeah, but if they're the same. Wait, these two, this is the same as this? Or
Yeah.
this is the same as this?
No, those two are the same.
But if you count both, wouldn't that be
You're not
too
doing-
big?
I'm not counting both.
Yeah, that's what I'm asking.
I'm doing the perimeter. I'm doing this distance straight across.
Okay, yeah, that's what I'm asking.
Yeah, I'm not going
you don't
down here.
count.
No. You just go straight across.
Okay.
Okay.
Got you.
No, when it doesn't make sense to you, you got to ask. All right. So for each of these, we're going to find the lateral area, the surface area, and the volume of each of the following. The first one is something that you could have done in 7th grade. Okay, it's not super hard. I always start by looking at, all right, what does the base look like? You don't have to draw it, but it's not a bad idea. It's a rectangle that's 6 by 8. Now, on this, since it's a rectangular solid, you could choose to use any side you wanted to. Any face could be the base. It's easiest just to do whatever's on bottom. So the perimeter, see, that's going to be 14 plus another 14 is 28. And the area of the base will be 6 times 8 is 48. So then the lateral area will be the perimeter of the base. So think about painting the walls of this if you want to think about it that way. You need to go all the way around, and you need to go all the way from the bottom to the top. So that'll be perimeter times the height. So the perimeter of the base we already found to be 28 times the height, which is 12. So that's 280 and 56 is 336 square centimeters. So then the surface area will be the lateral area plus there's 2 bases that we need to add on. So that's going to be 336 plus 2 times 48 is 432 square centimeters. And then the volume is the area of the base times the height. So it'd be 48 times 12. See, that's 480 and 96 is 5. I think it's 576 cubic centimeters. We're running a little bit late, so I'm going to skip number 2, but I'll just say real quickly, it says it's a hexagonal prism where the base edges are 8 inches, so that means every side of the hexagon is 8. And the height is 4. That's not talking about the height of the hexagon. That's talking about the height of the prism. How far is it from one base to the other base? For a cylinder, we're just going to real quickly do this one. The circumference is 2 times pi times the radius. So it's 2 times pi times 5 is 10 pi. And the area of the base is pi times the radius squared. So it's 25 pi. So the lateral area is the circumference. We want to go all the way around the figure, and we want to go all the way from the bottom to the top. That's what the lateral surface is. So circumference times height. So it's 10 pi times 16 is 160 pi square feet. The surface area is the lateral area plus, I've got 2 bases to add on. So it's 160 pi plus 2 times 25 pi is 210 pi square feet. And then the volume is the area of the base times the height, because now I want to fill it. So I want to cover the base completely and then fill it from top to bottom. So that's going to be 25 pi times 16 is 400 pi cubic feet. Not going to go through all of number 4 again, we're running a bit behind, other than to point out on this one that sometimes people get to this one and they're like, well, how am I supposed to find the area of that triangle? Well, you do have to know some Pythagorean triples, and this is one you're supposed to know. The sides of the triangle are 5, 12, and 13. That means it's a right triangle, even though they didn't tell you it was a right triangle. That's going to come up sometimes on your homework problems, where they don't tell you it's a right triangle. They expect you to know it's a right triangle because it's a Pythagorean triple. All right. Then let's look at composite figures. So when you're finding the surface area and the volume of composite figures, for surface area, it is never, ever, ever correct to find the surface area of the two different figures and add or subtract them. It will never turn out right. For volume, it is always correct to find the volume of the two different figures and add them or subtract them. Okay, so let's take a look at this first one. So what this is, and your book draws these better than I do by hand, but basically think about taking a block of wood and drilled a hole all the way through it. Okay? For surface area, you always want to think about what could you theoretically touch. So I always make a plan for the surface area. So for the surface area, can I touch the sides of the prism?
Yes.
Yeah. So the lateral area of the prism. Can I touch the top and the bottom of the prism?
Yes.
Is there part of the top and the bottom that I can't touch? What can't I touch? The whole, which is a circle. So this is going to be plus 2 times the base of the prism, because there's 2 bases, right? They're both the same. Minus 2 times the base of the cylinder, because you can't touch either of those circles. Here's the tricky bit to this one. Now that we've drilled a hole down through there, you can reach down into the hole and touch the sides of the hole, right? So that's additional surface that you couldn't touch before you drilled the hole, right? So plus the lateral area of the cylinder. So for the lateral area of the prism, it'll be the perimeter of the base, which is 12 times 4 is 48, times the height is 20, plus 2 times the area of the base of the prism. The area of the base of the prism is 144, because that's a rectangle, 12 on a side, therefore a square, minus 2 times the area of the base of the cylinder. Well, this cylinder has a diameter of 4, so what's the radius? 2. And so what's the area of that circle? Yeah, because it's going to be pi times the radius squared is 4 pi. Plus the lateral area of the cylinder, which is the circumference of the base, that ends up also being 4 pi, times the height, which is 20. So that's 960 plus 288
Wait, times the height.
times 20.
Why do you multiply?
Because think about painting that cylinder. You need to go all the way around, that's the circumference, and you need to go all the way from the top to the bottom.
It's like stacking pancakes.
Oh, then why didn't we put that in the first equation?
In what first equation?
Like the S equals LP plus 2VP.
We're just looking at what parts we need. We need the lateral area of the cylinder is one of the things that we can touch. We can touch the sides of the cylinder. So this would be minus 8 pi plus 80 pi. 1, 2, 4, 8 plus 72 pi. Square millimeters. So on the surface area, you just want to think about, well, what parts of this can we actually touch? Now for the volume, it's pretty straightforward. It's going to be the volume of the prism minus the volume of the cylinder, right? We had more material there to start with than we ended up with. We got rid of that part. So the volume of the prism is going to be 144, which is the area of the base, times the height, which is 20, minus the volume of the cylinder, which is the area of the base, 4 pi, also times the height, which is 20. So that's 2880 minus 80 pi cubic millimeters. Okay, let's make a plan for finding the surface area of this. With the surface area, you've always got a plan. So I usually start with whatever's bigger. So for the prism, can I touch the sides of the prism?
Yes.
Yeah. So that's the lateral area of the prism. Can I touch the top and the bottom of the prism?
Not completely.
Not completely. I can touch most of it, right? I can touch most of it except for what?
One circle.
Yeah, this one circle, I can't touch that anymore. The cylinder's in the way. So minus the base of the cylinder. Plus, on the cylinder, what can I touch? Can I touch the sides?
Yes.
So that's the lateral area of the cylinder. What about the top and the bottom?
You can only touch the top.
We can only touch the top. The nice thing about this is I've got to minus the base of the cylinder and plus the base of the cylinder. Those add out. Because this part that we can now touch exactly equals this part that we can't now touch. So those are going to drop out. Let's see, this is 80 times 16 plus 2 times, oh, I can't do that in my head, 26 times 14, 364. And the lateral area of the cylinder, if the radius is 3, the circumference is going to be 6 pi times the height is 12. So we end up with 2008 plus 72 pi square inches. And for the volume, it's just going to be the volume of the prism plus the volume of the cylinder. It's just stuck there on top, so we're adding those two together. All right, your assignment is in the book.